Hello YouTubers, RogueMonkeyJr here. So Respawn just released a blog post talking about Apex Legends servers. Now the blog post is called What Makes Apex Tick? A developer deep dive into servers and netcode. So this video is going to be split up into multiple chapters because this is going to be a long one. I'm telling you right now, there is a lot of information in this blog post and we're going to go through it thoroughly in today's video. So there is a lot of technical terms as well. So if you need to pause the video to go and search a term, please feel free to do so. But yeah, strap yourselves in as we get into this blog post. So starting off with the introduction. So he says, hello, I'm Rickle Saucer, lead engineer on Apex Legends, and today I want to offer you a bit of insight into the online infrastructure that supports Apex Legends. In the past, we haven't often talked publicly about servers, try like almost never, netcode or online infrastructure for Apex Legends, and today we want to begin to change that. In short, today we want to share a bit about how we're working to improve your online experience in Apex Legends, acknowledge and explain some common online issues or connectivity problems you may encounter while playing Apex, specifically address commonly asked questions about topics like slow-mo servers, hit registration, and how our lag compensation system works, offer some comprehensive notes on our server tick rate, and explain our thinking behind what it affects and what it doesn't. A warning, this post is long because it's intended as a true deep dive into the online infrastructure for Apex Legends, something we've seen some players requesting for a long time. We're thinking of this as a starting point of a longer conversation, so even though we do cover a lot of ground here, there's probably plenty of topics, DDoS attacks, server crashing bugs, etc. that we could spend more time addressing. By all means, if you like this blog, let us know what you'd like to hear about next time, and we'll keep it going. For those of you who are ready to geek out about netcode, servers, tick rate, and more, welcome. Let's kick things off by talking about some recent improvements we've shipped. So first and foremost, boosting our response time with performance metrics. In Season 6, we introduced the performance display. It looks like this and gives you basic information about your performance. In and out are the bandwidth consumed by the game in kilobits per second. You also have latency in milliseconds, packet loss, and packet choke are rendered as a % of packets per second. Those numbers help you and us understand what you're experiencing while playing. In other words, we can translate what you're feeling into actionable and technical information. Before this edition, we would hear from players that something was off, but they couldn't always tell us much beyond that. Now you can accurately say, I have 10% packet loss, 300 millisecond latency, etc. It changes everything because those numbers are often the best possible indication of what's going wrong. I'll come back to this point. While working on the performance display, we also began tracking key performance metrics for players and servers. This means that if someone reports problems, we can pull down their match and see everyone's data in the game at the time, including information about the specific server hosting the game. This represented our first big push to give personalized and targeted means of investigation to our team. We've had some successes with this approach, but we think that in the long term, it does not scale. First, we have to hear from you, then dispatch an engineer to see where the issue comes from, and then, depending where the problem lies, we attempt a fix. In recent seasons, we've begun leveraging the help of our awesome data science team to batch and crunch, gather and analyze 1 week of data at a time to detect excessive packet loss and server performance issues. This approach has been paying off already. For example, we found out that one piece of network equipment in our data center was faulty, causing every game hosted on a handful of servers to have horrible network performances. The servers themselves were fine, but the hardware that connected players to the servers in question was causing massive packet loss. We encountered plenty of examples like that. The main benefit we get from systematically analyzing data is that it lets us cross-reference metrics and players to find patterns. So week after week, we can confidently say if the health of our server fleet is better or worse. Data analysis is also a great tool to help our partners fix issues when it's something outside our control. Instead of saying something is wrong, we can say this specific thing is wrong, which saves time for everyone involved. By the way, you can opt out of this if you like, just go to gameplay and then usage sharing in the settings menu. So automation helps a lot, but it's not enough. Indeed, with this approach, we are still somewhat slow to react to problems. We need to wait a week for most data to be reliably gathered and reported to us. Then it can often take another week for a full investigation to be conducted. From the moment you start noticing problems, it may take us up to 2 weeks to find a fix, and even more to deploy the solution if it requires a server patch. We can do better, we will do better, so let's talk about solutions. First of all, in addition to our weekly report, we've moved to real-time alerting. It will give us the same level of information that we have now, just faster. We will be able to fix hardware problems right away or start investigating and working on a patch. We understand the frustration of having to wait, and we try to actively shrink the time between an alert and a fix. Second, we're going to introduce a new server unique ID, SID, to the performance display that will allow us to find the server you're playing on faster. At the moment, you give us a time and date, and we correlate that with the data we have on you to find the server you were playing on. Soon, we won't have to do that. We expect both of the above solutions to start rolling out during our upcoming season, Apex Legends Legacy. The result for players will be speedier resolution of server issues, sometimes twice as fast as currently. Next, a deep dive into common issues. Now to the fun part. Let's broadly categorize server issues you may encounter. The list below is not exhaustive, but I hope it answers most of your questions. So firstly, the server is running in slow motion. Everybody loves this one. Our servers are running at 20 Hz. This means that they simulate the entire world state once every 50 milliseconds, 1 second, or 1000 millisecond divided by 20. We don't speak about FPS or frames per second when discussing server performance because a server does not display pictures. Instead, a server computes states, but the underlying principle is the same. It takes user inputs from the network, runs the physics, sends back the new world state to clients, then repeats. If this process takes more than 50 milliseconds consistently, your game will slow down to prevent the server to finish the simulation. Thus, you get slow-mo servers. There are a number of things that can cause this, but it's sometimes linked to machines in the data center not performing as they should. Think about an underclocked CPU, overheating, etc. When we detect those, we usually remove those machines. This means we literally call up the service provider, point out the problem with the given machine, and ask them to take it offline. The real-time detection solution mentioned earlier in this blog should reduce this issue considerably when we roll it out during the upcoming season. We're heavily invested in solving this issue, so we're going to keep a close eye on it. Next, my latency is going up and down. If you play on Wi-Fi, we can't do much for you. Otherwise, rapidly changing latency can sometimes be related to our server performance. We all know that even if a game typically runs at 60 FPS, that can change when a lot is happening on screen. Even if you're only dropping a few frames, you feel it. It works similarly for servers. Here, automatic detection does not help much with determining the root cause of the problem. Historically, we've had to recreate the conditions of the slowdown on a dev server, but this is pretty time consuming and always a bit of a shot in the dark. Your machine probably doesn't run on the same server hardware or with the same settings, so it's hard to replicate anything one-to-one. Thankfully, our operations team produced a tool to let us get what we call a RPROF file. That was a mouthful. This is basically a view of what the server is doing during every frame: ballistic simulation, network in and out, player movements, etc. Thanks to RPROF files, we're able to know what's slowing things down, and an engineer can start optimizing. Usually the problem has something to do with increased performance demands introduced by new features season after season. You may remember, for example, the slowdown on the champion screen at the beginning of the game during Season 7 and 8. It was caused by all the players in the match spawning at the same place on top of and even overlapping each other, and you couldn't even see them because of the UI. Physics simulations really hate having some objects overlapping with others, and our physics engineer was trying to get all the bodies away from each other, causing massive CPU spikes on the server. Here you can see a graph of percentage of matches affected by a server with slow performance, not necessarily slow-mo per regions. You can see that some regions get better with time and others degrade, which is x-axis is time. So you can see that East Asia, West US are typically problem regions for these issues. Next, we have a detailed graph of US West region that allows them to detect faulty machines. Again, the x-axis is time. Outages are very clear on the charts. Some machines are affected while others remain stable. We anticipate that our usage of RPROF files is going to better help us optimize new features we add to the game and reduce latency more generally in the future. Lowering latency for all players is a big focus for us, and better tools like this are crucial for helping us get there. Next, talking about packet loss and packet choke. This one is extremely tricky. It's probably not your fault, and it's also usually not ours either. It has to do with how internet traffic travels from your box to our data center and back to you. At the beginning, your network traffic is on your ISP network. Your ISP may be having an outage where your information, along with other customers' information, is being lost/dropped. This results in the game client not knowing what's happening with the players around you, or the game server not knowing that you want to shoot your gun or move in a certain direction. There's also the connection between your ISP's network and our data center network. Problems can pop up anywhere along this line. When things go smoothly, we call this process peering. A lot of the time, peering problems result when a connection between two networks has a weak link. There can be multiple hops like this along the way, and then of course all the information from the Apex servers needs to go back to you, often by taking a different route. You can start to understand why this gets complex. If we want to help resolve this, the first thing for us to do is to be able to detect where the outage is. This is hard to automate because we need data from you and we need data from the server, so we can look at the issue from both perspectives and try to probe along the way to see where the problem is. As of today, we ask players to provide some kind of network traces, and we do the same on our side from the data center to try to detect where the congestion point is. This is extremely time consuming and slow to resolve because, depending on our findings, we have to negotiate with different business partners all over the world. We're hopeful that automation can help improve this process, and we have some improvements in the works that are still in early stages. When it comes to network traffic problems like the ones we're discussing, one good thing is that the problems tend to happen in bulk instead of being tied to any particular individual. This means that fixing the problem for one affected player usually unblocks a lot of others. We are also actively reducing the bandwidth used by the game, which helps to mitigate the problem. Next is the issue where you would get killed behind a door/wall and sometimes roll back to your previous positions. This is a spicy topic. It has to do with lag compensation. In every game since the dawn of online gaming, the main problem for developers to solve is how to fake real-time action in something that is not operating in real time. Essentially, everything you do in online games is delayed because of the latency to the server and back. A lot of the things add to this: inputs, rendering, and yes, even server tick rate. Even worse, on top of all that is your opponent, who almost certainly plays with a different level of latency than yours. To solve this, our servers have to constantly look at not only what's happening for you and your opponent at that moment, but also what was happening from both your perspectives at the time both of you input your actions. Lag compensation is the art of merging slightly different experiences into one shared reality. There is no perfect solution, there is not one truth. At the end of the day, the server is a sort of time machine. It constantly rolls back the world state to see if your shot hits someone and then updates the world for everyone accordingly. To better illustrate this principle, my colleague Earl Hammond wrote a little essay about fairness and lag compensation and how it all works in Apex Legends. I'm sharing it with you below. So this is Mr. Hammond. Let's go through various scenarios with two players in Apex Legends called High and Low. Let's give High a high ping of 300 milliseconds and Low a low ping of 50 milliseconds. The difference in their pings is 250 milliseconds. What happens if they shoot at each other at the same real world time? Well, Low's shot will arrive at the server long before High's shot, so Low has the advantage. What happens if one of them rounds a corner so that they can suddenly see each other? Well, Low has the advantage here as well. Low is less into the past, so they get to see High first. Once again, Low has the advantage due to their ping. This adds on to the advantage where Low's bullets get to the server faster. These cases are unfair in the sense that Low has an advantage, but they are fair in the sense that it's reasonable to expect that the player with the lower ping would get the advantage in this situation. Now what happens if Low goes behind a corner to get into cover? Well, High is still in the past when Low is not covered, so High can shoot Low before they get into cover, but Low won't find that out until High's packets have made it to the server and then to Low. By this time, Low sees that they're safely in cover, yet Low still got hit. From Low's perspective, this is a bit of nonsense. However, this is exactly symmetrical to some of the earlier nonsense that was in Low's favor. When Low pops out of cover to attack High, Low gets to see and shoot High, while it appears to High that Low is still in cover. From High's perspective, this is a bit of nonsense, that they got shot by somebody who is still in cover. This nonsense can't be eliminated, only transferred between one player or another, because of the simple reality that ping is real and players have different amounts of it. Some would suggest that it is unfair to low that high can shoot them when low thinks they are behind cover. The alternative they suggest is that high should have to compensate for their high ping themselves. This would require us to implement an unequal and asymmetrical way of handling latency. It feels bad to get shot when you think you're behind cover due to bad ping, which is what can happen to low. It also feels bad to get shot by somebody before you can even see them due to bad ping, which is what can happen to high, but the nonsense is distributed symmetrically. We want to be super clear, not all online games work the way Apex does. Some games always give the advantage to players with lower ping, but we actively choose not to with our system. It's a stance we've intentionally taken after looking at the trade-offs and thinking seriously about fairness in online competition. To explain our system in simple terms, players with low ping don't always have an advantage over high ping players and sometimes experience nonsense. To us, that's a technical term. That's a trade-off which is designed intentionally into our system. But the upside is that you can play Apex Legends and play relatively well even if you have a higher than average latency, which is really important for rural players, or for players in regions where connectivity is unstable. We believe we should reduce nonsense at every opportunity, but when we have to deal with less than ideal experiences, we want to do so in a way that's equal and fair to all players. This is the reason that almost any time you deal with a bit of nonsense like getting shot while behind a wall or getting hit right as you come around a corner, it's probably due to unavoidable variation in latency between players and the way our system distributes it. Still, we're committed to reducing this at every opportunity we get. Not only do we want everyone to have a fair experience, we also want you all to have a fun one. Next, talking about hit registration. Let's talk about hit registration. A no-reg or no registration of a shot means you think you hit your target, but the server basically disagreed. From your perspective, you get all sorts of confirmation in the form of blood spray and sounds, but no damage counter shows up. In a shooter like Apex Legends, this is extremely unpleasant. It can happen for a multitude of reasons. Sometimes high latency or packet loss can cause your local simulation to become slightly out of sync with the server. You shot where you saw someone, but actually you were shooting where they had been previously. Unfortunately, you don't find that out until your version of the world catches back up. Sometimes it's just a bug with the game's physics simulation. To give you instant feedback, we rely heavily on a concept called prediction. When you shoot, we know the ballistic of the weapon, so we can predict where the bullet is going locally without needing the server to tell you. This makes the game feel more responsive. Normally, the client and server agree and the bullet goes where predicted. In the past, we've had some bugs with this way we were computing ballistics and bullet trajectories for every weapon with a bullet size that was not a point, like sniper rifles for example. This kind of bug can be gnarly to detect, so we put a visual in place for our playtests to help people spot the issue right away. Sadly, this diagnostic code is too heavy to run in the live game because of bandwidth concerns, so we can only rely on our internal testing. There's two ways we're making progress here. The first is by constantly digging into the different bugs that result in hit detection issues. We've been developing tools to automate detection as well, so we can help developers avoid introducing any new ones. This will be an ongoing and continuous effort on our part. The second is to work with you. When players send us clips of hit detection issues in action, it can help us figure out if there's a bug we need to address. Often, we realize that clips we get sent actually have to do with a latency problem instead of a hit detection issue, so be sure to check your performance display before reporting a hit reg issue. However, as mentioned above, we have found and resolved bugs this way in the past, so reporting can help us make the game better for everyone. Thank you in advance. So next, talking about bugs that prevent people from logging in, like the infamous code net. Code net is a generic error message that the game displays whenever your game timed out from the server. It can be caused by a number of issues both on our end and yours. In fact, we found that some of the most serious code net bugs and related bugs like code leaf, etc. might have more to do with Respawn's services supporting the game that may need to be investigated. We've taken a number of steps to reduce the likelihood of a CodeNet bug occurring, and many players are able to have their situation resolved after contacting our support team. If you're unable to log in and are receiving the CodeNet message or anything like it, please consider reporting it using the EA Help site. I'll leave a link in the description down below as well as in the top pinned comment to that site. Since CodeNet is a generic message, it might refer to any number of different problems. We've had some success in recent weeks of addressing some of those, but we know we have more to do. Report issues to us and we'll do our best to resolve them ASAP. Trust us, we hate this bug as much as you. Moving on to server tick rate. Here comes the big one. We want to tackle it transparently. Plenty of players have asked us about our server tick rate and why we don't simply increase from 20 Hz like some other online shooters have. We've explained how tick rate impacts the overall refresh rate of what you see on screen, so this is a totally valid question. However, it's trickier than you might think to compare one game's tick rate to another's. We'll try to explain why. The tick rate of a server is the number of simulations that the server runs per second. It is a fixed number. See the section about slow-mo. Don't worry, there's a chapter for that if you want to go back. Apex uses a snapshot-based replication model. This mostly means that at the end of every tick, the server saves the world state and replicates it to all clients. This includes a lot of information that allows our weapon, map, and Legends design to be of the highest fidelity. To be successful in Apex Legends, you have to pay attention to a whole lot of information happening all over the map. Tactical abilities getting used, or passives activating, or ultimates popping off, or care packages dropping in, or a new squad entering within range of Crypto's drone. We don't want players to miss any of it, and our designers are able to create toys and tools that can be truly global in nature. Many games don't compute full world states on each tick, making it misleading to try to compare one game with another based on a single feature like 20 Hz versus 30 Hz. The question is, what exactly is happening during each tick? We want the world state to be as accurate as possible, which is why our servers save the full world state on each tick. If we didn't do this, it would probably save some of the CPU costs on our servers, but we would lose accuracy in our simulations, and that isn't worth the risk. Put simply, the higher the tick rate, the higher the bandwidth sent to all players. If we were to move from a 20 Hz server to a 60 Hz server, it would mean multiplying the bandwidth the game uses by 3. As of today, Apex Legends roughly consumes 60 kilobits per second at the beginning of the game. A 60 Hz server would consume 180 kilobits per second. That may not sound like a lot, but it's quite a bit, and we are always looking for ways to reduce the required bandwidth. But why would it matter if the bandwidth went a little higher? Keeping bandwidth costs low for games is much more critical than, say, for video streaming. For high bandwidth applications, streaming, downloading, etc., jitter or hitches are easy to hide by buffering minutes of a stream, dropping stream quality, etc. You probably won't be shown jitter in a download, and you probably don't care that the speed is variable by a few or even hundreds of milliseconds. Games do not have this luxury. Skipping even a couple 50 millisecond intervals can start to feel bad. Skipping a few more can send you into a death spiral of having to send you bigger and bigger updates to catch you back up. There are no exceptions to not getting you those updates because your client needs a perfect state of the world to be accurate. The above example shows how comparing tick rate between games is complicated because the information contained in each tick varies. There's another complication as well, which is that the limits on inputs that servers can receive and send out aren't always the same, even if they have the same tick rate. To be specific, in many games, if a server runs at 60 Hz, it means the client can only send 60 Hz inputs. If you run at 60 FPS, it's fine, but if your client runs at 120 FPS, you would lose half of your inputs. This is not the case in Apex Legends. We process variable rate of inputs fine. As a side note, the higher your FPS is in Apex, the higher your bandwidth usage is as a result. So if you run the game at a higher FPS, you might need a better internet connection to send the larger packets. Okay, so we've discussed some possible downsides that come with increasing server tick rate. But what about the upside of going from, say, 20 Hz to 60 Hz? Come on, Respawn, wouldn't that make the servers 3 times faster and 3 times better? Just do it! Based on our findings, it would not result in a meaningfully different experience, and we want to explain why. For the sake of argument, let's assume that you're averaging about 50 millisecond ping, or latency. Remember that your ping measures the speed of a full round trip between your machine and the server. So assuming there are no other problems like fluctuating latency or hardware lag, example, display devices introduce 20 to 50 millisecond delay. The server will receive your input 25 millisecond, half the ping after you press a button or flick your mouse. Since our servers are 20 Hz, they update the world every 50 milliseconds, so in the worst case scenario, your inputs will be processed by the server after 75 milliseconds, so 25 milliseconds, which is half your ping, plus 1 tick, which happens every 50 milliseconds. To figure out what that 75 millisecond delay actually means in terms of your experience, you have to think about your frame rate. The math here can get tricky, but remember that in a 60 FPS game, each frame takes about 16.67 milliseconds. If your inputs are being processed by the server after 75 milliseconds, as in our example above, and your game is running at 60 FPS, that means that the lag between your input and its impact on the game is about 5 frames. So 75 milliseconds for each update divided by 16.67 milliseconds per frame equals about 4.5 frames, and rounded up to 5 frames since there's no such thing as half a frame. If you do all the same calculations above for a 60Hz server, you get 41.67 milliseconds for the maximum delay between the input and the server processing it. So 25 millisecond ping plus 16.67 millisecond per tick would give you 41.67 milliseconds. 41.67 milliseconds is definitely better than 75 milliseconds, but what does it result in as far as frame rate goes? Let's again assume we're running at 60 FPS. Each frame takes 16.67 milliseconds, so now the lag between your inputs and the server recognizing them is about 3 frames. So put all this math together and you realize that 20Hz servers result in about 5 frames of delay, and 60Hz servers result in 3 frames of delay. So for triple the bandwidth and CPU costs, you can save 2 frames worth of latency in the best case scenario. The upside is there, but it isn't massive and it wouldn't do anything for issues that are tied to plain old lag, like getting shot while in cover, ISP level issues, or bugs like with hit-reg and slow-mo servers. Our example examined the upside of going from 20Hz to 60Hz. You can follow the math for other jumps like from 20 to 30 or even 40, and you'll find that the gains in frame rate would be similarly quite small. You'd need to increase server tick rate very drastically before you could really start to feel it. Even the jump from 20Hz to 60Hz would feel like the difference between 58 FPS and 60 FPS. This difference isn't nothing, but we sincerely believe that it isn't enough to prioritize tick rate changes over other more efficient improvements we could be making. So for closing thoughts, we want to close by acknowledging something, which is the very real and genuine frustration that online issues cause for players. When you have to deal with lag or no-regs or slow-mo servers, it sucks. It takes you out of the game and can feel very demotivating for you when you're trying to grind ranked or make some clutch plays with your friends or just having a relaxing evening. Part of the challenge about talking about online issues then is that when we start explaining our systems or our stance on issues like lag compensation or tick rate, it can start to feel really frustrating for players who just want the game to be better. If you have issues with latency or server crashing bugs or account corruption issues or any of the other challenges that you can come up against while playing Apex Legends, you probably don't want to hear about what we're not doing. Ultimately, we just want to make the game better. The better the online experience is for you, the more people will play the game, which allows us to keep doing the job we love. This is why throughout this blog we've shared a number of improvements that we're pursuing in the near future, including using real-time alerting that will allow us to identify problems and respond more quickly, implementing tools for identifying servers so we can remove and replace problematic servers rapidly, focusing on slow-mo servers. Removing problematic servers is one step, but our goal is to make this drastically less common with code changes, reducing latency with better optimization of new features, and fixing hit-reg bugs and building automated detection tools to help us avoid introducing new ones. But we want you to know that these aren't the only things we're doing. We're working with partners from the server level to the ISP level to improve and invest in our online infrastructure, with the ultimate goal of seeing players report fewer issues and a better overall experience. We intend to say more about these efforts in a future post when we've begun to see these efforts come to fruition. Our hope is that we start to communicate more with you about the issues that concern us. We'll begin to share more of a common language to talk about the root causes of the issues we're dealing with. That's why we wrote this blog post. We hope it explains our thought process and demystifies the technicalities of running an online shooter. And we hope it's the start of more conversations to come. Thank you for reading. Sammy, Ricklesaucer, and the Apex Legends team. Whew! Now that was a long blog post, so hopefully it gave you a lot of useful information, or maybe, you learned a little bit about what the issues are or what are at the root of certain issues in Apex Legends. Again, there's chapters to the video if you want to go back and watch certain parts, or listen to rather. This is really more of a talking video. And I'll leave a link to the full blog post if you want to go and check it out for yourself. But anyways, for those of you who are still here, if you enjoyed the video, hit the like button, subscribe to the channel if you haven't already, and as always, thank you very much for watching. I really appreciate it, and I'll see you guys in the next video. Have a good one.